Thanks for joining the session. We're going to be talking about modern web applications, a little bit on how they're built, and spend most of the time on how they can break. My name is Adam Hert. I'm a senior product manager here at SolarWinds, responsible for some of our application performance monitoring products. And joining me today is Mike Morgan, our senior technical advisor. Mike, thanks for joining the session.
Oh, it's great to be here, Adam.
And Mike, to start off with, we'll kind of set the groundwork. The old applications, I won't say old, but legacy applications, let's say, they used to be monolithic. They'd have the database, the code, maybe the web server, all on a single host, and they kind of did everything in one. They had their own issues, but now modern applications are quite different. Can you kind of tell us how are modern web applications built today?
Yeah, so modern web applications are less reliant on monolithic LAMP-style stacks and utilize more microservices that can be scaled horizontally to accommodate load. So if your app is under heavy load, we're going to be spinning up containers. We're going to be using serverless technologies to handle those requests.
Makes sense, and people are probably reaching for things like Kubernetes and running things in the cloud now. So definitely a different architecture with its own set of problems. And over the next 20 minutes or so, we'll walk through those problems. Let's start in the user's browser and see kind of what's needed to make these modern web applications work. We're going to start with a DNS request, kind of straightforward. We do our TLS handshake, then we make our HTTP request to the web server. On modern applications that are using single-page apps, instead of all the content being returned at once, it's going to return some JavaScript to us, which is executed in the browser, and then we make even more kind of AJAX-style requests and pull even more JavaScript to do kind of third-party tracking and all that fun stuff. So Mike, kind of walk us through, with all this going on just in the browser, what are some areas that can break and we need to watch out for?
Right, well, absolutely. Starting with DNS seems simple, but often not the case. I mean, an example would be the Cloudflare outage that occurred in July. Just a router failure in Atlanta just knocked off large swathes of the internet. A massive problem.
There's this old term that it's always DNS. It's probably a bit overzealous, but it can cause a lot of issues. And if you're running in the in the cloud space, you're probably not managing DNS anymore. This is managed by your users are using Google DNS, Cloudflare DNS in this case. And even if it's not your fault, I mean, when Cloudflare went down and we had this massive outage across the general internet, there's nothing you can really do about that, but it's still a way that these things can break, and you need to kind of be monitoring that and understand how that can affect you. And sorry, you're going to jump into another failure point there?
Yeah, I mean, DNS is, it's not just limited to large DNS providers. I mean, it can be down to individual user issues as well. I mean, things just like, VPN issues, even local DNS that you host yourself. I mean, it's a really a single point of failure that can affect any kind of operation that users are trying to request a site or something like that.
For sure. We use internal applications ourselves, and every once in a while I'll type in an internal address, and then the web application will break down, or I just can't get to it, and I forget I'm not on the VPN and my DNS isn't working. So pretty kind of, it's right at the beginning of this flow. We're just scratching the surface here, but absolutely DNS is an issue for both modern applications, things running behind a firewall for sure. And then moving on to TLS, you need to use TLS today. That your browser is going to yell at you if you don't. What are some things we need to watch out for here?
Yeah, absolutely. So things like, is your certificate valid? So, it's very, very easy. If it's not someone's responsibility specifically to look after certificates, it could just expire. And then that's going to be a problem. Your TLS connections aren't going to work anymore.
Yeah, 100% preventable. But I think we've all had some experience with TLS certs expiring. It'll definitely catch us. Also, I need to watch out for the versions of TLS we support now. So it seems like yesterday that 1.0 was retired, and now we all need to support 1.3. So definitely a preventable thing that we need to watch out for.
For sure. And definitely the certificate chains as well. I mean, chaining certificates is a complex subject. Something may look like it's valid, but unless it has the valid certificate chain behind it, that can also be problematic and can cause certificates to not validate correctly.
Right, that always kind of gets over my head a little bit, but something else to watch out for there. The next part here, the HTTP request from the browser out to the actual website. There's a couple failures here. I mean, the browser's making the request. If there's no network, right? If there's a firewall in the middle, if the network is down, that's going to fall apart. I guess it could be a server error there once a request hits the server, but we'll dig into that one a little bit when we dig into the real server side and all the complexities that are there. The next one here that's really focused on the browser is the content's returned from the server. It's back in the browser, but on these new modern applications, the content is it's really just a bunch of JavaScript and single-page applications. So what are some of the problems that can happen there when the browser's executing this JavaScript?
Certainly there can be errors in the code itself, right? So if there's some sort of problem with the JavaScript, then that's going to affect how the page loads, could ultimately cause just the page to not load at all, which is absolutely the worst case scenario.
For sure. And then, there's the other thing I guess to think about here too is JavaScript is single-threaded, right? It's kind of a weird thing that we're using everywhere. But if you have a lot of logic in your JavaScript code that's being executed in the browser, it's single-threaded, but it is asynchronous. There's just some complexities there that, hey, if your JavaScript, if you've written it in a way that you think, hey, this stuff is going to be kind of running in the background on somebody's kind of second core on their computer, not really the case. Kind of everything you do in there is kind of degrading the end user's performance. And then kind of the last point we wanted to cover here, so the JavaScript is returned from the server, it's executed in the browser, and then what happens there is as this JavaScript is executed, it's actually going to get the content for the page. It's getting more images. It's getting it's retrieving third-party JavaScript code just to make this even more overwhelming. So again, kind of the same problems. We can have network errors again. There could be firewalls. Again, since it's single-threaded and we start loading all that third-party tracking software and all that cool stuff we want on our web page, that's going to kind of bog down the website. So kind of some things to watch out for there. And we didn't cover everything in the browser. There's other things that can happen. But you know what? Let's jump over to the server-side application. And just in the essence of time, because there's so many ways that modern web applications can break, we're going to skip over load balancers, your API gateways, and the things that kind of stand in between the browser and where your custom code is running. So we'll start at really like the web tier. So the web tier is one of these. It's almost like your edge router if you're a network person, but it's the kind of the application that your users are actually interacting with and making their HTTP web requests to. So, Mike, when we're talking about the web tier where your custom code is running and really the other supporting microservices that are running behind that, what are some of the ways that these can break? And we'll talk about the database afterwards, but just in these custom applications, what are things that we need to watch out for?
Yeah, so we definitely want to watch out for things like errors, of course, exceptions that your code would throw. These going to be absolutely critical to keep an eye out for, monitor. In the event that they happen, we need actionable data as soon as possible so we can kind of work on those, resolve them.
And that's probably the the worst case, right? Or again, there's so many ways that you can break. We made the web request to our custom code, and immediately our code was written poorly, it threw an error, and we're done. We didn't make it further than that. So that totally makes sense. We need some error and exception handling in there. It's kind of like a catastrophic failure. What are some of the other things where maybe it didn't completely break? It didn't just throw us an ugly error, but things aren't going well and it's really slow. What are some other things we need to watch for?
Yeah, definitely the infrastructure that the application is running in. Ultimately, if your server is running out of resources, CPU, memory, all that kind of good stuff, then that's going to hinder the performance of the application.
Yeah, totally makes sense. Your things need to be provisioned properly. And I guess just to add on to that, you need to watch now auto scaling when you're running in cloud environments that if you're hitting these limits on CPU and memory, make sure that automatically adds a new server or go do it yourself just so you can kind of keep up with the demand there. That totally makes sense. And then, if we were talking about microservices, if you're running in Kubernetes, it's only even more complicated. Now we have to watch our memory and our CPU and make sure that things are kind of allocated properly across our cluster, which is still kind of a new problem that some people are dealing with. Anything else we kind of need to watch for kind of on that can cause poor performance and not maybe completely break things?
Definitely if the code is just written badly, that's obviously going to be problematic. So, if you have code that's just inefficient, taking too long to kind of work through itself. I mean, ultimately, that's going to just hinder the performance of the app, slow everything down. In itself, can cause resource issues. So, absolutely something we need that visibility around.
For sure. You know what? I was working with a customer one time that they had this application. It actually was kind of a hybrid, not super modern, but they had this one endpoint that took a lot of data and turned it into a CSV, and it was just super resource intensive. And whenever somebody hit this endpoint, it would just bog down the entire application. So yeah, keep an eye out for those functions and those endpoints that are inefficient, super resource intensive, and might be taking away from even other users' experience. The one other thing I wanted to call out here on the kind of on the web tier is just watching the configuration. So if you've got high volume, watch how many workers and threads you have configured to run this stuff. Sometimes little tweaks in there can cause big problems and big improvements. So just kind of keep in mind the traffic that you're expecting to run, and then tweak this stuff. Both the kind of amount of replica sets and the stuff in Kubernetes that you're running, as well as just making sure that the number of workers and threads kind of match the workload, so you're not creating these bottlenecks right at the web tier. Now we kind of talked about the web tier a little bit and the custom code there. What about the actual microservices? So now we've got, instead of one big monolith, there's 10 different services, or maybe there's 1,000 different services. We've certainly worked with customers like that. They're all working together to make this application run performantly. Anything we kind of need to watch between our microservices, ways that they can completely break, or ways that they can actually make for performance?
Yeah, I mean, definitely. As you mentioned earlier on, Kubernetes, huge thing for our customers. Everyone wants to be able to kind of break their app into microservices and use Kubernetes to manage that. But it's a very complex product. It's really difficult to configure unless you know what you're doing. And I'm absolutely certain that many, many people are not doing it completely correctly. And that in itself can be very, very problematic for performance.
Yeah, absolutely. And I was talking with a customer a little while ago that they had this old monolithic application running on-prem, and they were moving to the cloud, and they actually told me, hey, we're moving to Kubernetes next week, which sounds amazing. And then I spoke to them about a month later, and they said, yeah, we tried it, didn't work out. So there's a lot of gotchas in there. And it's funny, when we went through all the stuff that was happening between the browser and the web tier, network, DNS, all of that fun stuff, that's happening basically every time we're making a request between microservices. So, there's something like a dozen different networking options for Kubernetes. I don't know why we have so many that exist. And then DNS is its own thing in there as well. So again, there's just, every time you kind of add a new service and there's more complexity, there are more failure points that can catch you, not only completely break the application, but can cause slowness as well if you haven't configured this correctly. Okay, so we've talked about the browser, we've talked about the microservices and the custom code that you've written. We're already most of the way through this session, and we haven't even started on databases, third-party services, and all the other ways that the applications can break. We're not going to get to them all. This is not going to be a comprehensive list, because there's just so many ways that these applications could break, and we could have spent this entire time just on database. But database is important, so let's talk about the ways that these can be inefficient, they can be slow, and that they can completely break our application. So, Mike, I'm sure you've heard of lots of different examples, but what are some of the areas that these things can cause us issues?
Yeah, wow, such a comprehensive list. So inefficient queries would be the first one that comes to mind. I mean, your database performance is only going to be as good as the queries that you're writing.
For sure, and inefficient queries are kind of twofold. You could make a single query that takes a long time. I actually spoke with a customer one time that was using one of our tools, and they found out that one of their endpoints in their application, every time a user hit this endpoint, it made over 1 million queries to a database. So imagine that. I mean, I think they must have been efficient queries themselves, but when you have some sort of n+1 query loop and you've got 1 million queries, that's going to cause some issues. Anything else other than these kind of inefficient queries?
Well, just bad SQL statements in general, something that would just generate errors. Again, going to hurt the application performance, perhaps even raise exceptions in your app.
Yeah, makes sense. I mean, even if you've got all the infrastructure there, if you've written something poorly in an SQL statement that's throwing an error, that's going to go bubble up all the way up to the end user. Totally makes sense. Infrastructure things, anything you kind of worry about, things you've seen from customers run into before that are kind of common gotchas?
Oh, absolutely. in particular, not enough resources for your database server. So particularly for those unmanaged database services, if you just have something that's in a very, very busy application hitting a database that does not have the system resources to accommodate it, then that's going to be just horrible for your application.
Totally makes sense. And one of the ones I've seen before, this is actually on an application that I was building. It was with a MySQL one, and it returned this error that said the MySQL server has gone away, which is just a ridiculous error message. Obviously, the MySQL server was still there if it sent me that message. But sometimes if these things are so bogged down, they just give up and they just say, "Hey, no, MySQL's not here anymore. Go figure it out." So definitely watching your infrastructure resources, making sure it's provisioned properly there. Also, just wanted to call out quickly on the kind of the PaaS or platform as a service side. Things are a little bit different there as well. You have to watch your provision throughput. Once you've hit your limits there, you'll start to get rate limited, and the database will send you back specific messages to say, "Hey, slow down to these rates." And if you don't observe those messages and react to them, it'll cut you off completely. Again, kind of that more modern MySQL has gone away, but hopefully a little bit more friendly. We should mention cache quickly. They kind of go hand in hand with database, but anything we need to watch there?
Absolutely. There's caches themselves can really speed things up, but they have to be watched carefully to make sure they're performing as they need to. So certainly things like under provisioning the cache cluster, that in itself becomes a bottleneck, right?
For sure. And I guess one of the other things too is this cold starts when your cache really isn't there yet, hitting the database too much, and just not using the cache enough. I'm sure that guy that was doing 1 million database requests should probably be caching some of that stuff, I would hope. And you know what? Again, there's so many ways that your applications can break or be inefficient and slow. We are kind of running against the clock here, but there are some other things that aren't, your application or the database. Mike, what are those other things that you might not think about at first with a modern application that we need to watch out for?
Yeah, absolutely. Things like just network services and DNS that you might be giving responsibility to a third party. It's great because it takes the onus off you, but then ultimately the onus becomes on them. And then if they break, then you're broken.
Totally makes sense. And even if you're making requests out to third-party APIs, network and DNS becomes an issue once again. Every time you add another dependency, all of these issues can prop up again and again. Just some other areas too, like serverless architecture comes with its own problems. We're not going to have time to cover it. There's background jobs that can conflict on resources. You might have data pipelines. I'm sure I'm missing some things here. Anything else you can think of?
Just the speed of your storage that you're using would come to mind.
Right.
Ultimately the files need to be stored somewhere. If the storage isn't up to par, then
you could have moved to S3 and that's not the speed you were expecting it to be because it's not really designed to be, a super fast database. Yeah, that totally makes sense. There's some problems you can have in there. Okay, so we are racing against the clock. We've been talking for almost 20 minutes and we've been keeping it pretty high level. I think one of the lessons here is that, there's almost a limitless number of ways that these modern web applications can break.
Yeah, and regardless of what your stake is in the application, whether you're the application owner, the support guy, or the operations guy who's ultimately maintaining this, I hope we've conveyed the importance of having appropriate monitoring so you have visibility in these issues and gives you the data to fix them when they go wrong.
Absolutely, yep. Talk through these issues with your team, get some observability in there, and I hope you found this session useful. Mike, thanks for joining us today.
Thanks, Adam.